this. Okay, it's recording now. Okay, so this lesson is going to be on components. What kinds of components? See, that was the problem. Typically in other classes and the progression of your your journey in learning electrical engineering is that you're going to be taught components and properties and things that happen to it. So you got resistors, capacitors, you got inductors that we didn't directly teach, but it's it's not as used as a that's not as often used as capacitors and resistors. So we keep that as a theoretical thing and focus on the practice of like the actual physical thing and its common uses. And what we went after is a bit of diodes and then the transistors. And in the normal class, what you'll get into is a bit more of different kinds of signals like AC and DC signals, some other kinds of components like amplifiers or linear regulators. But that's a lot of things. And you're never going to you're going to learn about these things. You're going to be using these things. They are useful, but but there's gonna be way more components out there than you think. So after giving the baseline of being comfortable with KVL and KCL, so Kirchhoff's laws of working with electronics and working with microcontrollers and all that, at this point you're kind of familiar to kind of comfortable working with electronics. And now what's going to be next is the rest of the components, just the rest of the components out there. I'm not going to be teaching you specific components, but I'm actually going to teach you like how to learn about these components. This is the bit of lesson where this is the part where they don't really teach you from classroom to industry, because in industry we do this all the time. Like we look for components, we analyze them, see if they're a good fit, and then put them in. Or if we don't know a thing, we look them up and see its properties. And that's not taught in a classroom. That's not taught in a lab even. So I'm going to teach you now how to navigate this environment, and I'll give you the reasons why we're loading this to begin with. So the first bit here is going to be choosing components. And then the next next half is going to be identifying components. What we'd start with is our Arduino. So this is what we've got. And if you've done the transistors lesson, let's start with a circuit. A simple NPN transistors connected to ground, connected to some pin in the Arduino. It's typically 5 volts. And then have an LED with a resistor. Let's say 24 volts for this one. And 220 ohm resistor. So I'll start you with, this is just a drawing. There are many different kinds of components that can be a 220 ohm resistor, that can be an LED. And there are thousands of different transistors and different transistor brands out there. The resistor that you know looks like this. So this looks like a 220 ohms. I don't memorize the brands, I just look them up. But I see the red. I use this enough to make it seem like I think this is 220 ohms. So this resistor could be this thing. But in the same time, it could be this thing. This is a resistor. Both of them are resistors. There's nothing electrically, they do the same thing. But in application, we use them for a completely different thing. This is mainly for prototyping with your breadboard, and other prototyping as well with a perforated board, where you need to solder things instead of just sticking things in like a breadboard does. This is for PCBs. So this is what's called a surface mount. So surface mount component, and this is a through-hole component. In an application, you've been using these through-hole components like this, and that's exactly what they're used for, using to stick it in breadboards and perfs boards. And for surface mount components, you can probably see it in your Arduino right now, that there are surface mount components right here. That's a resistor. And just to show that there are more different kinds of just a resistor, a 220 ohm resistor could be a different thing as well. There's this one. This is also a resistor. And this is roughly the size of half your palm. This is not a tiny thing anymore, it's a lot bigger. And its applications are for things that are bigger. So this is a bigger, this is a server, a picture of a server room where they're next to its next to a heat sink with a fan. So this is for higher power things. So, and this is still a resistor. It's just for a different application. And to note things down as well. Oh, before I forget, this is a panel mount component. Or chassis mount. Any questions? Okay.
No.
Thank you. Okay. Another thing here. In this picture of a surface, in the surface mount resistor, there's this thing. Those are capacitors. And they look like this, typically for surface mount. You've had for a through-hole capacitor, you've had this or something that looks like this. And for the big kinds of capacitors, it's this. This is the size of a cup, basically, with similar applications just for high voltage systems. So as we learned that just now, that one component can be very many things and is corresponding to many different things. And that's what we're going to be navigating through when you're buying components. This is essentially looking for components online for your designs, and then eventually purchasing them and putting them together, and then making your circuit. And what we're going to be using is a site called DigiKey, and you can find things on Mauser as well if you're familiar with them, but typically it's on DigiKey. So just so we can finish up the circuit, because we're also there's other components here. For simplicity, this is just an LED that we all know about. Oh. Something wrong with my thing. Oh no. Cannot change. Oh, okay, give me a second. Share. Oh. Share screen. Nope. Hold on. Let me just finish my thought up for this. Just so for simplicity, this will just be a regular LED that we know of, but this is a transistor that we want to design for. So let's say you're designing the circuit on a PCB. Hint, hint, we're going to be doing that, or you're going to be doing that on the team, if you ever want. So these are skills that you'd want to learn, designing PCBs, and let's build this as a PCB. But we're going to need the components for them. So let's say we bought a surface mount capacitor like this, and the big question mark is this thing. So this is our NPN transistor. Now I've posted the lesson and the tutorial assignment for just this weekend. I think it was this weekend. And we're going to have, our circuit is going to exactly be this. So there's going to be 5 volts going into the base of the transistor, and then 24 volts going through the collector emitter side of the transistor. So we're going to want a transistor that will first can handle 5 volts at its base. Needs to turn on at, so this is for max value, and then the can turn on with 5 volts. So this is pin 2. Can turn on with 5 volts, so the minimum value of it turning on, and also the maximum value that it could allow current through, or actually voltage through. So can handle 24 volts on, this is the collector emitter, so this on VCE. And typically when you say V base, you can typically say VBE. So this is base, emitter, and collector. So we want a transistor, we choose a transistor with these properties. So before I proceed to the DigiKey part, does anyone have any questions? I'll take that as a no.
I have a question.
Oh, okay.
So it says there, can handle 5 volts max, and then underneath it says can turn on with 5 volts minimum. So how come 5 is the max and the min?
Well, no, 5 is what we give it. What we're looking for is the values of its minimum and maximum.
Okay.
This is the max value and this is the min value. Think of the min value as typically when you put 0 volts into the base of a transistor, it doesn't turn on. It turns off. It doesn't activate. But there's a minimum value of voltage where if you send that voltage, it will turn on. It's like the threshold.
Okay.
So that's also typically called V threshold, but it varies between datasheet to datasheet of component.
Okay.
So so our circuit has hard values of 5 volts and 24. And we're picking a component that fits in that value. Does that make sense?
Yeah.
Cool. Any more questions?
No.
Okay, let me just get straight to sharing the other screen. Share a different screen. Is it still recording? It is still recording. Okay. If only I could share a window like Discord. Can you see my screen?
Yeah.
Cool. Let's go to Google. Okay, so open up your browser or whatever, and I'll show you 2 websites. It's very often used by all of us, any electrical engineer, and like all the students that are buying things for their projects. Typically, when you buy things, it's in Amazon, and it's the easiest and best place to buy things for yourself. But if there's specific components you're typically needing, website is going to be looking for is DigiKey, digikey.ca. The other place people buy things in is Mouser, so moser.ca. These are the 2 websites if you want to buy components for your electronics projects. This is the place to be. Typically, if you can't find the specific component in one place, you can find it in the other. But typically, the most reliable is DigiKey, more than Mouser. Right, so just for an example, let's check out our resistors that we were talking about earlier. I'll look up resistor. So I'll help you navigate this website because this is the website we all often use. So there are lists of resistors here. There's through-hole resistors, there's surface mount resistors, and there's chassis resistors, the chassis mount resistors I've been talking about. There's different kinds as well. Typically, just choose which one that you'd be looking for. So let's say we were looking for a 220 ohm resistor in our circuit. Let's say it will just be that, and you'd have this whole bag of beans. This is a bit overwhelming, and there's almost 1 million results for just a lousy resistor. So what I typically start when I'm looking for a product is click in stock, I click data sheet, I click active. So that that whittles out all of the obsolete products and products that are not discontinued. So that went from 700,000 to 70,000. Still a lot, but it's a lot better than we can work with. We can choose also, where is it? All of the other points over here is a lot more specific. There's typically only one, other than in stock, data sheet, and active, there's only one or two other things that you want to worry about, and that's resistance. So we want to buy a resistor that's of a specific resistance value. What we were looking for was 220 ohms. This one's 2K, 200 ohms. There's 220 ohms. Now it narrows down to 311. It's just 300 resistors. Now we have our resistance value, and our part status is when we buy things, it's there. Now actually choosing a component. First thing you should click is the cheapest value. I know this is at $1, but these things are so tiny, and each is the size of a grain of sand, that these are dirt cheap, really. So what you have to do is click this top button of price, and it'll take you to the cheapest resistor that I could find. This is 2 cents even. So we click that, and this is the part that we'd get. And if you're designing a PCB, you'd be wanting this part number and then putting that into your project. But this is just me giving you an example of looking for a part. We have our surface mount part. That is 220 ohms. And that's kind of what we're looking for. There's no wrong answer in choosing this. Just choose the cheapest one. Just, if you can save money, why not? But yeah, that's how we look for components. However, we were looking for a transistor here. So let's look up transistor. Well, specifically a BJT, because if you went to the previous lesson, you've learned that there are 2 types of transistors, a BJT and a MOSFET. And so specifically, just for the simplicity, we're looking for a BJT. MOSFETs are typically more used, but the BJT is what you have in your parts kits. But in this case, we're looking for a surface mount BJT. So let's just so there are pictures here, but the pictures are typically misleading. It doesn't clearly say that oh, it's surface mount. Oh, this is a through hole. Oh, this is chassis mount. Oh, this is a kit. It says it's a kit, but what do these mean? So just for a rule of thumb, if you're not sure of what to pick on the top results, always find something with the most number of items, because that's where it generally would be. All the parts that you're typically looking for. So even if the top results don't pop up, you scroll down here, just look for the most number of items. So even here, it gives us some other things, which kind of doesn't make sense. I was asking for a BJT, but the same thing pops up right here, 14,000 items. So you want to click that. All right. From here, let's go to clicking in stock, data sheet, and active, making sure we're when we look for a part, it's able to be sold to us and able to be shipped for us. And now here we go. This, what's the value that we're looking for? Unlike a resistor, which has an actual resistance value, the transistor isn't as clear and defined. We know what a transistor does, what a BJT does, but why are there? It's the same function. There's so many things that are available to us. Well, first off, let's click up a surface mount device because we're making a PCB. But that's where what we've defined earlier comes in handy. It should be able to handle 5 volts, and it should be able to handle 24 volts. 5 volts on the base and 24 volts on the collector emitter voltage. So first off, let's scroll to the side here and click surface through hole. Oh no, surface mount. So click surface mount, and that narrows down our results. Go back to scroll back to the start here. We were looking for an NPN transistor. There's going to be a lot more transistors. Typically, just choose the one that you're familiar with. Some manufacturers just want to be fancy and put two components in one device. But stick to the things that stick to the things that you're used to and is familiar to you. If you need an NPN and a diode, and if you need an NPN and a Zener diode, yeah, sure, you can click that. But for what we're looking for an NPN transistor. Okay, so what I've defined that you want the V base to be, it can handle 5 volts at maximum and 24 volts in to the collector emitter. Before I continue, does anyone have any questions? They don't have any hard time getting into this point.
I don't think the transistor lesson is up.
The transistor lesson isn't up. What? That's stupid. I will publish that right after this. I saved it. I've written it. Huh. Okay.
It says it's unavailable until week 5 module.
That doesn't make sense. I didn't put it in week 5 module. Okay, I will post it right after this.
Okay. Sorry to be the bearer of bad news.
No, it's okay. As long as it's still there. I know it's there. And I have a separate file saved, so nothing's lost like last time. But I will just post it. You can go over that as well as this. This would kind of be confusing to y'all, but good thing this is recorded. Okay, so continuing on the base of the transistor, we wanted 5 volts. On the collector emitter side of the transistor, we were looking for it could handle 24 volts. So just looking over the labeling, it says voltage collector emitter, and we need to say it needs to be able to handle 24 volts. So in DigiKey, you can click 25. That's its maximum, and you can drag all the way down like this. So click 25 and drag down to include all of this. Anything higher values typically means it'll be a more expensive part. But for us, we need at least 25. And if we find cheaper transistors that can handle 50 volts, that's just better for us, better for our applications. Okay, doesn't seem too clear. So for anything else, so I'll just click apply all for this and click price to the cheapest one. You won't really go wrong with any of these, so I'll just click the 4th one down because I'm familiar with on semiconductor. Okay, let's see what it could handle. So it could handle 30 volts, so it fits our criteria. And there's not much information about the base. Okay, so the main point about this lesson is looking at data sheets. Data sheets is what we stare at all the time. Any engineering you'd look at, you're going to be staring at some kind of table or some kind of data sheet, is because we're very applied. We're actually buying, getting physical things and getting it to work. First thing you typically look at is the pinout. You'd expect the base to be the third one over here, but it actually isn't. The base is this little corner over here. And the collector emitter is in those other pins. So all before moving forward, just glance at and skim through the pinout of the component, and then and then you'll know how to connect this up. And also take a look at it again. This is the data sheet is your best friend when it comes to some components you don't know. So, oh, there's different. So this data sheet itself goes over different components. So this component is specifically BC848B. So 848 here, that one. BC848. So BC848 can handle 30 volts DC. Okay, cool. That's what we're looking for. And the emitter base, so sorry, base emitter, either way, it's the same thing. That's for the 848, is 5 volts as well. So we're good so far. It's not, this component isn't gonna smoke up if we put this together. But now our question is, what's its minimum turn on voltage? You gotta zoom in, you gotta know what you'd be looking for. What do these values make sense? Small signal, like there's a lot of different tables here. There's 14 pages of information for just a very tiny component. There's off characteristics, on characteristics, small signal characteristics. This is pretty overwhelming. There's a lot of information here. Just filter out the things that it probably isn't. For example, output capacitance, noise figure, current gain, bandwidth product. That's some electrical engineering words that I don't feel like looking into. It's probably not what I'm looking for. Base emitter voltage for on characteristics. Is that what I'm looking for? Somewhat. Yeah, somewhat. That seems like something that I'd be looking for. 5.8, 6.6 millivolts. Base emitter saturation voltage, 0.7, 0.9 volts. Base emitter saturation voltage. Oh, collector emitter. Collector emitter is probably not what we're looking for, but this is on characteristics, and we're looking for something that goes down to the base emitter, so it's probably one of these two. I won't get really into what saturation and non-saturation is, because that's covered in the YouTube video. Should have been posted in the transistors lesson, but I will go do that. And I'll post up this lesson as well. And it says our value is between 0.7 and 0.9 volts. Okay, so I think we got all our values that we're looking for, and this is not a bad transistor to pick. It can handle our power source that's powering the LED, and it can handle our signal that's coming from the Arduino. Does anyone have any questions? Cool. I'll take that as a no. I'll now transfer back into the share. Yes. Let's stop share for a sec. Ah, shit. There we go. Okay, so we got our value. So whatever component that was BC484 something. Component is BC484 something. Make sure you keep the link. If this was able to share Windows, I'd tell you to keep all these part numbers and links in a notepad file or just some place that you could copy paste into. But Zoom doesn't want to share window, so let's share screen. So share window. Assume that I did copy paste into a notepad file just so it's saved somewhere. This minimum value that we looked for was between 0.7 and 0.9. So that's the value you should be looking for. So the signal be turned on. The maximum value is 5 volts. So it's right on the limit, but it's still probably fine. If it were me, I'd choose another transistor a transistor could handle a 6 volt maximum. But as it stands, a 5 volt maximum is good as well. And then the transistor we chose can handle 30 volts. So it can handle 24 volt signal along the collector emitter. So the collector emitter line. So in a nutshell, that's what choosing components is like. That goes towards every component that you could conceive out there. Does anyone have any questions before I move on to the next thing? Okay, cool. So that's in general choosing components. What we did was we chose a resistor and we chose a transistor. But in your kit that you have right now, you have a bunch of different kinds of components. You have a breadboard, you have a bunch of wires, but you also have some circuit boards on there. What do those circuit boards do? How do I know what to look for them? This is I'll just open up the link. Oh, I need to share the window again. But before I move on, this is the image in Amazon of the kit that you've gotten. It's just a quick overview of what's in there, and it's actually not all of what's in there. There's more things that it says that it doesn't show. But you have kind of no idea what this is and what this is. What are these? You're not too sure, and it's not very obvious what it is. It's not a transistor. It's not a capacitor. It's not an LED. It's not a diode. What are they? These are entire circuits that you're given in your kit. These are motors, but do I know how to use them? That's the second part about this lesson, is looking into the things that you don't know and learning up on things that you don't know and seeing what you've gotten and learning how to identify what you have. First of all, this useful thing is a power board. So to look it up, there's numbers there, and the actual numbers in the Amazon screen, it'll show it better. It's 5-4 shit. Can't remember. Let me just open it up and share my screen again. And the other thing. Let's open up Amazon. There we go. And I'll send you this link as well. Where's the chat? There we go. And oh yeah, I'm so dumb. You can also just physically look at it, but I do not have this device. I have all the other devices, but not this one. but it's called the Elgo 545043, right? So looking, typically many devices have a part number. So in this case, the only part number I see is 545043. All the other signs in it is it says 3 volts, 5 volts, a DC in, a switch. Not sure what they do, but you can start with looking up 545043. So I'll agree. 54503. And you'll discover that it is a power supply. A power supply that you can use to power your breadboards. This switch is able to toggle it on and off, which is pretty cool. As you can connect these barrel jacks. So your kit also comes with a barrel jack. So right here, the thing connected to a resistor, a battery. You can put the barrel jack on there, and you can also put the barrel jack on your Arduino. But as it stands, you can also put the barrel jack here or another USB to power up your breadboard kits. You can also control the type of voltage that you're giving it. So it's 5 volts or 3.3 volts. And typically what you'd like to see is somewhat of a YouTube video. So you can see this in action. I want to hear you. And he can show you how to use it. And more information comes from articles and YouTube videos. So I suggest you get used to looking stuff up and learning about what they do. But this is one of them. This is one of the cooler products that you've gotten on your kit. My module doesn't have that. Oh, rip. Yeah, but on the intended one, it has this. But there are other components in there that we could look into. One of them is, well, this thing. There's these ICs over there. There's these rectangles with leads on them. And if you can look at them a little closer, it says SN74HC595N. So, okay, that's a sexy name. Rolls right off the tongue. So SN, that's not it. SN. Always typically start in Google, but I think for this one, you can actually use DigiKey as well. And just to save me from copying, I think it's in the list here. Yeah, HC595, sure, I'll use that. Oh, the SN is a different thing. The other one is HC595. But I'll look up HC595 anyway, or HC5, whatever. Okay, apparently, looking at the items rule again, let's go to the most number of items we've got. Let's go to in stock, data sheet, and active. Lowers the amount of stuff we've got. There are surface mount components here, so let's just click through hole because that's the component that we have. Okay, we have 3 results now. And by the looks of it, 3 results of the same thing. The 74HC595. This is SN74HC595. This is a longer name. Let's just go with the top one here. And what we've discovered that it's a shift register. Huh, okay. Now, what's a shift register? And that's also something that you can learn. It's very essential when it comes to building computers, building your own microcontroller. That's what the Arduino is built out of. This is one of the components that build up into an Arduino. And I'm going to be linking you this video just so you can learn what's going on there. This just uses LEDs and resistors and centered around this guy, the shift register, and just a few buttons. So I'll be linking this video as well. Another important thing, and I think this will be the second last thing I'm going to be showing, is the motor. So let's go back to the parts list or refer to your physical parts in front of you. Now it should have I do have this motor physically on me and I'm looking at it. So if you could pick yours up and look for a part number to look up for, because it has leads and signals, then you're not quite sure on which is positive and which one's negative and which one's control signal. So that's what you're going to be looking for. But luckily, in the Amazon page, it's stated that this servo motor is an SG90. So I can go look up SG90 servo motor. And I'll specifically look for the data sheet. That's really all we care about. Typically, it's the first one up. And there's the motor. All it needs is a connection to power, so positive, and a connection to ground, negative, and a signal, from your microcontroller, a PWM signal, something called a pulse width modulation, which we'll be teaching you in the next lesson and introducing to you in a little bit. If you want to use the motor, there is also a how-to video that I'm going to be posting of how to use the servo motor. And the only thing you really need is your Arduino, some wires, and the servo motor itself. You don't need any other extra circuit. And you can control it with just by software. So that's available. And the last thing I'm going to be teaching you is one of the components in there called a thermistor. So it's this guy, that little squiggly, that, how do I do this better? Share screen. This guy, typically, if that's not a thermistor, I'm not sure what else it would be. So if you have something that looks like this, that would be your thermistor. Photoresistor. That could be a photoresistor. I really don't know what part looks like which. I have different components on my kits that I have, and I've bought my own parts in other places. So it might not look exactly like what you've got. I think that may be the photoresistor or that may be the thermistor. I am not sure. I think thermistor is the one next to the LED. So it's this black one. Okay, cool. So in your guys' kits, that'll be the thermistor. Yeah, this looks like photoresistors. I don't use them as often as I could. But yes, this little black thing will be your thermistor. And what it is just essentially a resistor that's variable by temperature. So that is a variable resistor whose resistance values change by the physical temperature. So you could blow on it and its resistance will go lower, or you could rub your hands in it or squeeze it with your fingers to use your body heat to increase its temperature. To increase its temperature, that's about it.
What's an application for it?
We're actually getting there right now.
Okay.
Grab your kits. So I drew up this circuit that Courtney's been preparing to help you guys start out on coding the thermistor. So here is the circuit. I'll just keep that there for now, and y'all should start copying. The application for thermistors is it essentially is a temperature sensor, and it's one of many temperature sensors. There's thermocouples and thermometers. That's a way to sense temperature, but in this case, it's able to sense the temperature of its environment. and change that into an electric signal. Because all we typically understand, all of our computers understand, are electric signals. It can't really tell, oh, the temperature changed. It needs some kind of medium for it. It needs something for it to sense. So this is your very first sensor, or one of the first sensors that you'd be learning, a thermistor. So you're going to be building up this circuit, and yeah, I'll just walk through it right now on how I built this, or how we've built this. Here's part of it. Since the Arduino only reads temperature, voltage, we're gonna have to use a voltage divider to send the signal, send a lower voltage from it to the Arduino. So that's going to be a variable resistor, and we don't really care what the specific value of this resistor would be, but we care about everything else beside it. So we're going to send it 5 volts because that's what the Arduino is able to send it. So 5 volts are all connected to the Arduino, and ground is as well, but you should understand that by now. 5 volts will be connected to the Arduino, and it'll go through a 10 kilo ohm resistor and goes through our variable resistor to ground. And this will be our input circuit. So we're going to be sending 5 volts, changing it into some other voltage that's stepped down according to this formula that you've learned in the resistor divider, and the resistor sections of the course. And as an output, we could use this. We could use the same pin, digital pins with a squiggly line on it, and output them to a transistor flowing through an LED. But to make things easier, let's just use this circuit where it doesn't have a transistor and it just shoots out to the LED directly. Since the transistor lesson isn't up, I will be you'll understand why we'd prefer the one on the top before, why we'd prefer a transistor there as opposed to not having a transistor there. But this is sufficient enough for this lesson at least. So this is going to be our sensing circuit, and this is going to be our output circuit. And yeah, I'll leave this up. I'll stop recording right now because we are now at the end tutorial section of the lesson, where we'd be sitting around here doing this with you. And yeah, I'll just say goodbye to the people who are watching this in the future. Later.